Hello. Good afternoon, my dear student. Uh, because of internet problem, the connection has been disconnected. Anyway, let us start with the uh, admittance parameter. Admittance parameter, I just told you that this is the ratio of current and voltage variable, and its unit is mho, just opposite of impedance parameter. And you see there are four y parameters: y11, y22, y12, and y21. Okay, now we will convert convert z parameters from z parameters to y parameters. Okay, z parameters to y parameter. Later on, we will try to convert z parameter to h parameter or t parameter. So, okay, let me tell you another two parameters. After that, we will discuss about conversion of different parameters. Okay. Now, this is admittance parameter, z parameter. Okay. Now you just see the expression of h parameter. H parameters h parameters or hybrid parameter. You write in small letter, or hybrid parameters. Sometimes it is called mixed parameter. Hybrid parameters. Okay. So for this parameter, here we have considered the input port variable V1, I1 are dependent variables. Okay, in this case we have considered V1, I1 are independent variable, and V2, I2 are V1, I2 are dependent variable. Let me write it. Let us consider, in this case, let us consider uh, V1 and I2 are dependent variables, but I1 and V2 are independent variables. Okay, now you can write the relation of these two variables. So you can write V1 dependent variable equal to parameters independent I1 plus H12 V2, and another dependent variable is I2 equal to H21 I1 plus H22 V2. Okay, these are two equations for each parameters. Okay, you just write this is equation 3, and the lower one equation 4. Okay, see each parameter, for each parameter we consider V1 input port voltage and output port current. Input port voltage and output port current V1 and I2 are dependent variable, but I1 and V2 are independent variable. If you uh, carefully look at the equation 3 and 4, then you can easily understand that for this case input port voltage and output port current are represented in terms of input port current and output port voltage. That means mixed kind of thing. In previous two cases, when we have calculated Z parameters and Y parameter, admittance and impedance parameter, that time we have considered either port 1 or port 2 voltage are independent or dependent. On the other hand, I1 or I2 are dependent or independent, like this. Okay, but in this case we have considered voltage and current both as independent variable and also dependent variable. Okay, so therefore this such type of parameter, or this parameter is known as are known as, these parameters are known as hybrid parameter or H parameter or mixed parameter. You see, V1 equal to H11 I1 plus H1 to V2, I2 equal to H21 I1 plus H2 to V2. Here you see that V1 I2 we have considered, but in previous cases V1 V2 I1 I2 we have considered as dependent variables. So that's why this is mixed variable. Okay, this is clear why this such type is called or are called hybrid parameters. Okay, and now you can calculate the x values of h11, h12, h21, h22 by considering the port condition. If you want to calculate h11 value, then you can write h11 equal to v1 by I1 at V2 equal to 0. That means output port is short circuited. So you just write yourself and you tell me the expression of H11, H12, H21, H22. Okay, let me write. It's easy for you to compare the expression. So H11 we can write H11 equal to V1 by small letter, not capital, H11 equal to V1 by I1 at V2 equal to 0. That means output port is short circuited, and H12 equal to, you just compare your expression with this expression. H12 equal to, you can write V1 by V2 at I1 equal to 0. I1 equal to 0. That means input port is open circuited. Okay, you write H12. Okay, then you write H21 equal to how much? I2 by I1 at V2 equal to 0. V2 output port is short circuited, and H22 equal to, you can write I2 by V2 at I1 equal to 0. That means input port is short circuited, open circuited. So you just write a small letter H. Everyone see H. So here you can write within bracket that V2 0 means output port is short circuited. That is output port is short circuited. Okay, and here you write S2 H22, you write that input port is open circuit. Input port is open circuited because current is 0. Similarly, you can write that output port is short circuited for this case, V2 equal to 0 is to one case, and for H22 case you can write input port is open circuited. That's why I1 current becomes 0. Okay, no doubt. Okay, Shine Vish. Okay, you write your who actually did not write roll number in a previous video lecture. You can write here, no problem. And now you see that age 1 1 2 2 expression are like this. Age 1 1 equal to V1 by I1, V2 is 0. Output port is short circuited. Age 1 2 equal to V1 by V2. Input port is open circuited. Age 2 1 equal to I2 by I1. Output port is short circuited. Age 2 2 equal to I2 by V2. That is input port is open. Okay, Nivedita. Thank you. So now you tell me the unit of this parameter, age parameter. What will be the units of age 1 1 parameter, age 1 2 parameter, age 2 1 parameter, age 2 2 parameter? You tell me the unit of individual age parameter. There are total 4 parameters for age parameter: age 1 1, age 1 2, age 2 1, age 2 2. This is a set of parameter. Each parameter has total 4 individual parameter: age 1 1, age 1 2, age 2 1, and age 2 2. Now you tell me the unit. You know the unit of impedance parameter is ohm. Unit of admittance parameter is mho. Now you tell me what will be the unit of this parameter. So age 1 1 parameter, you see it is the ratio of voltage and current. So you can easily write its unit is ohm. Age 1 2, you see this is a ratio of two voltage, input port voltage and output voltage, V1 V2. That means this it has no dimension, unit less, or this mho. H1, okay, that is admittance is correct, or now you tell me the units of H parameters. Okay, so V H 1 1, the unit of ohm, volt, age 1 2 amp. No, or 3. You just see the expression of age 1 2 and age 2 1. Age 1 2 and age 2 1. You see this is the ratio of two voltage and two current. That means the unit will be cancelled out from denominator and numerator part. Therefore, it is a dimensionless parameter, unitless parameter. So age 1 2 has no unit, and age 2 1 also it has no unit. Okay, unitless parameter. 3, you just correct the unit of age 1 2 and age 2 1. Remaining are correct. Age 1 1 unit is ohm, age 2 2 is mho. Okay, but age 1 2 is a unitless parameter, and age 2 1 is also an unitless parameter because it is the ratio of two voltage terms and two current terms. Okay, therefore these are unitless parameter. Okay, everyone try to understand why age 1 2 and age 2 1, okay, are unitless parameter. Why? Because you see that they are ratio of either current or voltage. Both numerator part and denominator part contains current or voltage. That's why a unit of current from numerator and denominator part are cancelled out. Therefore, this is a dimensionless parameter or unitless parameter. Okay. Now let me tell you another important parameter, that is transmission parameter or ABCD parameter. Okay, and then we will try to convert one parameter to another parameter. Okay, now let me tell you transmission or ABCD parameters. Okay, in this case you have already realized that to calculate or to determine the values of this parameter, we need to write the two-port network equation by considering four variables, and among these four variables we will consider two as independent variable and remaining two as dependent variables. And by making a relationship between this independent and dependent variable, then we can easily calculate the parameter expressional value, whatever the parameter, y parameter, z parameter, h parameter, and ABCD or transmission parameter. So let me write here. In this case, we will consider input port voltage and current are dependent variables. So let me write it. Let consider here V1 and I1 are dependent variables and or but you write but V2 and I2 are independent variables. Okay, actually different condition here, input port to output port transmission, that's why input port parameters are independent variable, output parameters are independent variables. So you can write independent variable. So therefore we can write the equation for the two port network in terms of transmission parameter like this. We can write V1 equal to A V2 minus, you just note down here that, or notice here that negative sign comes in the equation. A V2 equal to B I2 and I1 equal to, you can write C V2 minus D I2. Okay, this is the most important part of this equation, negative sign. So far whatever we have considered all are associated with positive sign, but in this case we have considered a negative sign because in previous cases for admittance, impedance, H parameter, we have considered that I1 and I2 current are entering into the circuit. Everyone carefully understand this important point, that in previous cases for Z parameter, for Y parameter, for H parameter, we have considered that I1 and I2 current are entering into the circuit. But for transmission parameter case, we have considered that I2 current is leaving from the circuit. That's why negative sign appeared in equation 5 and 6. Okay, why negative sign appeared in equation 5 of 6? If we compare these two equations with our previous equation, then we can easily understand that a negative sign appeared in this case, but for previous cases only positive signs appeared in the equation. The difference is that previous I1 current, input port current and output port current I2 are entering into the circuit. But for this case we have considered I1 current, input current is entering into the circuit, but output port current I2 current is leaving from the circuit. That's why negative sign comes or negative sign appear in our equation. So from this equation everyone can easily calculate the expression of, or easily determine the expression of A, B, C, D. What will be the expression of A? A equal to, you can write V1 by V2, I2 is 0. B equal to minus V1 by I2, V2 is 0. C equal to I1 by V2, I2 is 0. D equal to I1 by I2 minus I1 by I2, V2 is 0. Okay, similar way you can calculate. So therefore you Now you can determine the expression of any parameters, maybe z parameter, y parameter, h parameter, or a parameter, by knowing the values of input port and output port current and voltage. Okay, to calculate the value of these parameters, maybe z parameter, y parameter, h parameter, abcd parameter, whatever, we need to know the values of voltage and current for individual port. Okay, we need to know the value of v1, i1, v2 and i2. Okay, variable, then we can easily calculate the values of the parameters. Okay, values of the parameter. Any question or any confusion regarding the parameters of a two-port network? At first I told you that two-port network is an important network. It has a it has application, it has a wide application in the field of filter design, in the field of transmission line or medium, in the field of matching network design, and also transformer. These are common examples of two-port network. So we need to understand their theory part or relation between input port and output port voltage and current. You can design a two-port network according to your demand, according to your demand or your specification. You can design yourself. Okay, or even if you want to study the equivalent model of a transistor or AC for AC application, you need to know the concept of H parameter. Otherwise it is difficult for you to understand the equivalent network for AC cases of transmitter circuit. Okay, now we will try to convert a parameter to another parameter. For example, suppose you know the values of Z parameter. Now I ask you calculate the value of H parameter. Calculate the value of H parameter of a two-port network. You know the values of Z parameter. If you know the values of Z parameter, then how do you calculate the value of H parameter? You can calculate the value of H parameter. This concept, okay, you can consider input port voltage, output port voltage, input port voltage, output port voltage, current, etc. And by knowing their value, you can calculate H11, H12, H21, H22. This is the direct approach. But if you know the values of Z11, Z12, Z21, Z22, then how do you calculate H parameter? By knowing the value of Z parameter or by using the values of Z parameter. The logic behind is that if you use the values of Z parameter to calculate H parameter, then it is easy for us without a rigorous calculation. Okay, if you want to calculate H parameter using direct approach, then you need to know the values and need to calculate the values of v1, v2, i1, i2, etc. Okay, then further steps are required to calculate h1 h1 to h2. To avoid this calculation part, we can calculate h parameter values by using the z parameter values. Okay, so this is alternative approach, or you can say this is one easy approach. We can calculate the parameter values by knowing the values of other parameter. Therefore in this case we can say that there are two types of parameter. One is desired parameter, another one is given parameter. Desired parameter means you want to calculate the value of the parameter. Given parameter means the values of the parameters are provided. Okay, the values of the parameter are provided. Now you convert the values of z parameters to y parameter, or you can say you write the values of y parameter in terms of z parameters. Okay, convert. This approach is known as uh, conversion approach, parameter conversion approach. Okay, two-port network parameter conversion approach. So let me share with you the steps involved for this case. How do you calculate the values of the desired parameter using the values of given parameter? Okay, so let me share with you the steps involved in this approach. Okay, first thing, you write the network equation. You write the network equation in terms of desired parameter. Then you write the network equation in terms of given parameter. Okay, you just see the slide, present slide. Okay, here I have written. And step 3, you rearrange the equation of step 2 in such a way this should be similar to the equation of step 1. After that, you equate the two similar equation of step 1 and step 3, and you just calculate the values of desired parameter in terms of given parameters. Okay, first you see the steps, or you read out the steps carefully. So to determine the values of desired parameter in terms of given parameter, we will write equation in terms of desired parameter as well as given parameter. After that, we will rearrange the equation of given parameters in such a way that the given parameter equation must be same as the desired parameter equation. I will explain it with an example, by taking an example, and then we will equate the two equations. Then we can easily calculate the values of the desired parameter in terms of y parameter, in terms of given parameter. So let us consider z parameter as the given parameter. Okay, convert z parameters to y parameters. Okay, then what we will do, first step is you write the network equation in terms of desired parameter. What is the desired parameter for this case? You first write desired parameters for this case is y parameters, y parameters. What is the given parameters? Given parameters are z parameters. Okay, now you write the equation of the two-port network in terms of z parameters and y parameters. Okay, z parameters and all. You know the equation. You write in matrix form. It is easy for us to calculate this, to solve this problem. Everyone write in matrix form. Okay, so z parameter, you know that v1 comma v2. This is the matrix from, equal to, you can write a z11 z12 a z21 z22. Okay, and here you can write I1 comma I2 as a row wise. I have written, but you write it column wise. Okay, v1 by v2. This is the equation for uh, uh, z parameter, given parameter, actually given parameter, matrix from of given parameters equation. Okay, two equation. And what is now you tell me uh, the equation for y parameter. You write matrix from for the of matrix from of desired parameter equation, matrix from of desired parameter equation, desired parameter equation. The desired parameter for this case is y. We want to calculate y parameter values in terms of z. So for this case you know that I1 I2 equal to you just write y11 y12 capital y1 or y12 y12 y21 y22, and here you write in terms of v1 comma v2. Okay, this is equation, matrix from of equation. Suppose this is equation 1 and this is equation 2. Now you write equation 2 as equation 1. How do you write it? So you just write I1 I2 in terms of V1 V2. So if you change this thing, then you can write, let me write it, rearrange equation 1, rearrange equation 1, rearrange equation, not equation 1, equation 2. The equation 2, rearrange equation. Everyone try to understand. If you face any problem, you rearrange equation 2 in such a way that equation 2 equation in such a way that equation 2 should be similar to the equation 1. You write equation 2 in you rearrange equation 2 in such a way that it should be similar to the equation 1. Equation 1. So how do we make it? We can write here I1 comma I2 equal to, you can take inverse of this thing into V1 V2. This, if you take this thing, this matrix, okay, to the left side, then you need to take an inverse. If you can write inverse, so you just this is z parameter, you write this inverse, then you can write v1 comma v2. This z equal z11 z12 z22 z12 z21 z22. Okay, sorry, you put minus sign here. Okay, z inverse, z equal to this thing, z11 z21 z22. So it is right. Now you write this is equation 3, equation 3, and you see equation 1 and equation 3 same. Okay, equation 1 and equation 3 similar. Now you equate them, make it similar. Okay, make them equal. Then what you can write? You can write this y11 y12 y21 y22 equal to z inverse. You can write, if you write this is y. Okay, instead of this thing you change it. Let me write it here. You write it y. Okay, y means y y11 y12 y21 y22. Now we can write by comparing equation. You just write by equating equation equation 2 equation 1 and equation 3, equation 1 and equation 3. we can write y equal to this matrix equal to, look at this equation, equal to z inverse. Any doubt? We can write this thing z inverse. If we compare equation 2, equation 1 and equation 3, we can write y equal to z inverse. Y equal to admittance parameter equal to inverse of impedance parameter. Okay, if you have any doubt or you have faced any difficulty to understand this point, you would write in your chat box. Okay, first thing, we have expressed or we have written the network equation, to put network equation in terms of given parameter and desired parameter, and we have represented this equation as a matrix form. After that, we have rearranged the given parameter equation in such a way that it should be similar to the equation or matrix form of equation 1. Okay, after that we just equate or equal, we just make them equal by comparing equation 1 and 3. We can write parameters, y parameter is equal to the inverse of the z parameters, and I hope all of you know the procedure for calculating the inverse of a matrix. You know the steps which are required to calculate the inverse of a matrix. What are the steps required for this case? You know, first step is to calculate the determinant of the matrix. Second case is calculate the adjoint of the matrix. You know, inverse is equal to the ratio of adjoint of the matrix to the determinant of the matrix. Let me write it here. It equal to, we can write this equal to, you just let me everyone write it yourself. You can write y admittance parameter equal to adjoint of z parameters divided by determinant of z parameters, determinants of z parameters. Okay, you just write determinant of z parameter, you know, and you know the adjoint of z parameter is the transpose of its cofactors, so you can write, ultimately you will get, if you want to calculate the cofactor of this term, what will be the cofactor of z11, z22? Okay, what will be the cofactors of z12 minus z21? What will be the cofactor of z21 minus z12? What will be the cofactor of z22, z11? And now you take transpose, then you will get z11 minus z12 minus z21, z22 minus z12 minus z21, z11. Okay, adjoint. And determinant equal to, you just take multiplication of diagonal elements z11 z22 minus z12 z21. Okay, any doubt regarding the calculation of inverse of a matrix? If you have any doubt, you write in your chat box. The first thing is to calculate the inverse of Z matrix, Z parameter, a Z matrix. How do you calculate the inverse of a Z parameter matrix? You just take the adjoint and you divide it by its denominator. Okay, first you calculate adjoint, then you calculate determinant of Z and take ratio of these two terms. How do you calculate adjoint of a matrix? Adjoint is the transpose of its cofactor. Cofactor is, how do you calculate cofactor? You just consider the element for Z1. If you want to calculate the first Z11 element cofactor, you just take cancel out this part, only Z22 will be remaining term. So Z22 then minus I plus J, I plus J minus 1 whole to the power I plus J. A term is coming in front of the parameter. You just see, okay, then you can easily understand. No problem. If you face any problem, then I will tell you. So for the Z11, you just cross this part, Z22 you will get, and Z12 minus 1, 2 plus 1, 2 plus this is the first row 1, and second column 3, 2, 1 plus 2 3, so minus 1 whole to the power 3 means minus 1, so you will get minus Z21. So like this you will get minus for this case minus Z12, and this is Z11, and if you take transpose then you will get Z22 minus Z12 minus Z21 Z22. So let me write it here. Then ultimate you will get Z22 minus Z12 Z12, then you will get minus Z21 Z11, and then you take determinant will be Z11 Z22 minus Z12 Z21. Okay, okay, so therefore y11 will be Z22 divided by Z11 Z22 minus Z12 Z21. This will be divided, this will be actually, this term actually associated with each term is Z parameter, each term within the bracket. Z22 divided by this denominator part, determinant part, minus Z12 by this determinant, like this. So y11 equal to Z22 divided by Z11 Z22 minus Z12 Z21. Y12 equal to minus Z12 divided by the same term. Y21 equal to minus Z21 divided by same term, and Y22 equal to Z11 divided by this 11 divided by the same term. So this is the conversion of Z parameter to Y parameter. If you know the values of Z parameter, then you can calculate the values of Y parameter. Okay. Thank you everyone. In next class, we will solve some problem related to two-port networks, and we will try to uh, convert Y parameter, Z parameters to H parameter or ABCD parameter. Okay. Thank you. And one thing, tomorrow I will take quiz for virtual lab experiment, and tomorrow group B first half, okay, first half student will appear from group B. Okay, I will send you the details. Okay, So tomorrow first half of group B, first half of group B student will appear for quiz, and day after tomorrow, day after tomorrow, first half of group A student will appear, and the remaining student will appear for quiz next week. To next week, okay? Let me stop here.